Hi, I'm Roger Margolis, and I'm with Kari, the CEO of Manceps. Welcome.
Thank you, Roger. It's nice meeting you.
So here at the TensorFlow conference, we're seeing a lot going on. What do you think is behind the AI revolution we're seeing here?
Oh God, a lot of things are happening, and I think I want to start with a little story. If anybody read Dilbert and the initial stories that started Scott Adams in writing was about how humanity started and how there were some monkeys, and then somebody started writing, and then somebody invented the printing press. And when someone invented that printing press, a lot of people got smarter, and then one day someone invented the internet, and that's when things got so good because we got a lot more smarter. And with AI, things are accelerating so much. But if you think about the components of AI, how AI came about today, how did we get to see all these technologies? If you think about, break it down to the core parts of it, think about all the data we've been collecting. That has been a phenomenal wealth that we did not know how to use in the past. And today we're actually doing so much better at understanding data and processing it properly and feature engineering to actually get meaningful insights out of it. In addition to the data revolution, of course, there was the hardware expansion, the new abilities we're seeing with better hardware every day, the better algorithms that are being developed every day. But if you think about this, the cloud made for something phenomenal to happen. The cloud made everyone able to take that data with a credit card and process massive jobs of training and learning from that data with just a little bit of money. And that really helped a whole new breed of startups that use that AI, those new AI technologies, to start new services and offer new offerings and products that helped really with all the stuff that is happening all around us, which we are accepting slowly and gradually. But if you think about it, if you tell someone who was at the time when Scott Adams wrote his first Dilbert book, would think of as science fiction. In addition to all that, the community developed this new concept over time called open source. And open source made things so much better. We started building incrementally on top of the shoulders of giants. So we learned from the past, we open source our products, we open source our code, we open source our technologies, and somebody else improves a little bit on top of it and makes it a little bit better, and someone else makes it a little bit better incremental improvement, and we are progressing so much faster than the past, almost exponentially. And finally, I think what's enabling this really is all the great work that is available for free by trainers that are helping millions of people learn the technology and get passionate about it and understand it better. A new generation is starting to learn about things that have that are significantly complex by just watching YouTube videos or watching online training and building some amazing products. Some high schoolers are now coming out with products right off of their high school before they even get to college because they're able to learn all these technologies super quick.
Yeah, and just for what it's worth, O'Reilly has a learning platform too that a lot of people use to get that knowledge.
Yeah.
So a lot of companies are under a lot of pressure to automate. What's behind all that?
Well, think about that, Roger. If you're that company that's selling products and you're not implementing AI today, well, Jeff Bezos is. And if you're not worried about losing your customers because you can't even keep up with their new requirements, their needs, and address their demands on a one-on-one basis, somebody else is doing that. If you're into content delivery and you're not thinking about how to tailor to the taste of your customers or your viewers, well, Netflix is thinking about that. And if you're into logistics or supply chain channels, if you haven't started thinking about ways to optimize that with AI, well, Walmart have done that. And you know, we are seeing a number of companies go out of business very quickly, just with other companies using techniques or technologies that allow them to learn better about their customers. In fact, if you think about this, 52% of the Fortune 500 list from the year 2010 is gone. 52% of those companies. And guess what? Who would have thunk a company with an app like Uber would unseat an established taxi industry and become the 60 billion giant company that it is today. Who would have thought that something that disruptive could happen to an industry that existed for thousands of years? Who could have thought that a company like Sears that owned almost a database of every individual on the face of this continent and failed to use that data for actually learning from it and delivering results through it, is on the verge of bankruptcy. It's very disruptive, and that disruption is all over the place. It's across the board. Every industry is going to be touched, and it's going to be all around us. We either adapt, and those companies that are smart enough to actually adapt and jump on it are really maintaining their competitive advantage over others.
So that kind of leads to, so there's this great need for AI, and a lot of businesses probably that aren't ready for it need to be. How does Manceps fit in? What does even Manceps mean? And
yeah,
what do you
Manceps
do?
is actually Latin for customers. It actually is a, it represents our focus and commitment to our customers. And we are a research and engineering company headquartered in Portland, Oregon. We work specifically on the AI machine learning space. We help develop solutions and scale those solutions out for our customers. And we take AI to the next level. We not only take data and help drive insights from it, but we also help take that data and serve it in a scale-out fashion to customers all around the world.
So for companies who might be interested in what you're doing, how would they get a hold of you or find out more?
Well, we are headquartered in Portland, like I said, but we work across the country in the United States and North America, and we're starting to operate globally. We can be reached at manceps.ai, and there's a lot of details there on how to engage, and we look forward to working with you. We really look forward to hearing what problems our customers have and what issues we could solve for them. We have a significantly brilliant team of data scientists and machine learning engineers that are hungry to solve problems and are really excited about all these applications that are out in the world that we can help solve.
Great. So you kind of described somewhat how you're helping customers, but in particular, what kind of things are you helping them with?
Think about the technologies we're building. Think about all of these solutions that are coming out so fast. Everything is evolving very quickly. When you talk about TensorFlow, for example, a major framework that's being used for building AI systems today, TensorFlow had a major release every 2 months for the past 2 years. It's moving so fast, and it's really building to deliver significant value by adapting some of the libraries that are already built in. A lot of that is moving much faster than a lot of companies can adapt to. And the way we operate, we help customers by initially introducing them to AI concepts and how that could work. If they are in a green field and they haven't gotten any AI yet, we start by optimizing some of their systems with some AI systems that could work with some of their data. We also put that into a learning mode and start slowly moving them into an optimized and augmented fashion. So as their new systems are optimized, they start learning from their human operators. They get to incrementally start augmenting. And one day, when we have enough training data and when the systems are delivering enough confidence, we flip the switch. When we flip that switch, the human operator stays. The person continues to actually operate the system, but only for anomalies and for exceptions. And the AI system handles the majority of the workload. And that allows the human operator to go on to doing better and bigger things and more important things, and things that require more creativity and more thought out processes.
So as anyone who plays in the data space knows, data is really important. Data quality is really important. What about customers who don't have enough or the right kind of data?
That's a really good question, right? I think it's very important to realize there are so many ways to actually acquiring data. You don't need to have data yourself. There are massive repositories of data sets that could fit your use case for just that initial learning. Before we actually start with full-on automation, as we get into the augmentation space, we could use other sources' data. There are public data sets, there are data sets that you could buy, but there's also one more important thing that is so amazing. With the open source movement, we are actually seeing large companies take massive data sets and train models with them and open sourcing them. Like take BERT, for example, a language model that was trained with all the knowledge of the internet, with Wikipedia and the New York Times and everything, to understand language. It costs about $250,000 in GPU time cost in the cloud only to train that model with that kind of data. And Google just took on that cost and trained it and made it available publicly. So you could actually take that model, use it for a starting point, and then train it or fine-tune it with specific problem data, and use it to actually make better and better inference as it trains more that is specific to a problem. A few of our students in the local school district, in the high school students through our internship Summer of Code program, took that model and used it to unredact documents. They were very successful at actually producing unredactor.com, an app that will allow you to write text, redact it, and then let the model predict what has been redacted. I think we all know why we need that. Yeah. And the other thing is that those models can be trained with specific type of data. For example, they could be trained on legal documents. They could be trained on medical documents. So we're able to take things like a domain that has a lot of content, a lot of documents, digitize those documents, and then use models and fine-tune those models with those documents, and summarize. If you're an attorney who is still reading hundreds of pages before you do discovery, or you have hundreds of paralegals sitting just browsing through thousands of pages to get the main aspects of a case that you could go and litigate, you're really wasting a lot of time and effort. An AI system could actually take multiple thousand documents and in minutes only generate a summary of the most critical parts of that case and help you really get to the key points that you need to pay attention to. Not only you can do that, you can also correlate elements of that case between timelines, other cases, some of the information that are available publicly, and that is adding superhuman capabilities to our law firms and customers in that space. Same thing can be applied to to medical records, to things like all the information that providers exchange with insurers, with suppliers, and all that, and doctors. It's a lot of documents, a lot of text, and all of that takes a lot of time from someone with an MBA to just go through, or some doctor to actually read a whole lot of text just to come up with a simple determination of a case being this or that. All of that is in the language processing space, is advancing so quickly. We now not only know the sentiment behind the text, we also understand the meaning and the concepts that are driving the intentions behind the text that we're reading. We see computer vision advancing in so many different ways. And at our session here at TensorFlow World this year, we explored an adversarial attack on neural networks problem, where neural networks could be potentially manipulated with an adversary that's also a neural network, learning from all of them and attempting to break them. We demonstrated that live, and we open sourced it. So we're gonna be happy to see what people think of that. We're hoping people will not use it maliciously.
Okay. So you talked about some great examples of things that work. Maybe you can do a little like separate the hype from the reality in this space, which is like filled with a lot
Yeah,
of
that's actually fun. That's my favorite topic. So a lot of the hype around AI is around what Hollywood showed us. We're not building the Terminator anymore. But are we close to self-driving cars? Probably we are, but not that close yet. But when you take that same concept and apply it to specific domains, like the agriculture, for example, agricultural automation is so much easier than self-driving cars. You don't run over people when you're out in the fields. You don't have that risk that is inherent with a self-driving option. So some of the applications we keep hearing about are advancing so fast, and we're seeing some amazing technologies coming out of them. But a lot of the hype is around things that could be done that we read in the science fiction books. One of the things that I think are really important to notice here, machine learning and AI are systems that are able to learn from a large number of dimensions. If you're talking about a problem that has so many different features to it that we in our limitation are unable to understand because of our ability to handle depth, when you train a machine with the multidimensionality algorithms that we have today on something that is simple, like take for example the weather, you train it on what the weather patterns were in say the 2010s. And you take simple features like temperature, clouds, wind speed, and so on, and you train that network with it. And then you take that model you trained, and you come and apply it to today and try to predict the weather tomorrow. It is actually able to predict the weather tomorrow much better than the weatherman, without knowing anything about the weather. And that in itself is very powerful in actually helping us understand, well, maybe we were missing the dimensionality of the world around us, and maybe that is something that the machines are going to be capable of analyzing better than we do and provide us with some insights we never were privy to in the first place. So I think there is a lot of hype around what we see as applications, but there is also the flip side to that in some way, machines could actually turn out to be a lot more intelligent than we are in that aspect. Machines go into general artificial intelligence is a nice dream. It's a beautiful plot for a science fiction movie. But I don't think we should be driving that. That's really should not be our ultimate goal. Our ultimate goal should be to utilize these new capabilities to have those superhuman skills.
Great. Well, thanks a lot for your time today.
Thank you so much for having me. I appreciate it.